Hello, everyone. Welcome to my session, Hardening the Secure Firewall. Before we start, I would like to introduce myself. My name is Srini, or Srinivasa. I am one of the next generation firewall technical leaders working in the CX security organization. I have more than 11 years experience working with Cisco. I initially started off working as an ASA firewall engineer and eventually started focusing on the next generation firewall. I am a dual CCIE, both in security as well as data center. While I'm very passionate about firewall technologies, I try to keep exploring and keep myself up to date. Some of my hobbies include playing volleyball, cricket, and watching some crime thriller movies whenever I can. Here's a picture of me during a cricket tournament, which happened a few weeks ago. I would encourage you all to go to the Cisco app and join the discussion. During the session, if you have any questions, or even after the session, if you have any questions, I would encourage you to please post them. I have a couple of my colleagues who are watching these questions live and answering you as they come in. We have 60 minutes, and we have a lot of content to cover, so I would encourage any questions you may have to hold them until during the end of the session. We'll take them. Here is what the agenda will look like today. We'll start with the introduction. Why do we have to really harden the firewalls? Data plane hardening involves any traffic which is hitting the firewall and is intent to leave the firewall. What kind of data plane process does it go through? Something similar for control plane hardening as well, where some of the traffic may be intended to the firewall itself or maybe to the FMC. So we'll take a look at some of that. And then VPN hardening, logging and monitoring. What kind of options do we have for logging and monitoring? It is always essential to have good monitoring for a healthy network. Then we'll take a look at some software and content updates. There are a lot of updates the firewall needs in order to do its core functionalities. Although compliance and performance best practices are available, we will not be talking about that, just because we only have 60 minutes and they are available for you to download in the PDF. And if you have any questions going through the PDF for these topics, you can still post your questions in the WebEx chat. And then the conclusion in the end. Over several years supporting the firewalls, I've witnessed and learned how networks can be degraded and left vulnerable just by missing out on implementing some very basic or simple best practices. And those are the exact best practices I'm trying to go through and bring them over to you during this session. Most of you probably will agree that firewall component or firewall in a network is one of the most critical network device. Just because it handles or controls any traffic going outside of your network or any traffic coming into your network. By hardening the firewall configuration itself and trying to minimize the threats, if your goal is to minimize the threats, your job is half done just by configuring the security best practices on the firewall. Some of these best practices, even though they look like one time, they are not. They are continuous, ongoing process. You'll need to continuously evaluate and put an effort to minimize these every few times in a month or maybe in a quarter. So enhancing network security, minimizing risk, preventing unauthorized access, mitigating malware and cyber threats, and maintaining compliance requirements are some of the tasks which involves as part of this security hardening. Before we dive deep, I would like to quickly go over some of the terminologies we will be using during this session. The first is FTD, also known as Firepower Threat Defense, or the new name Secure Firewall. It's a unified software image which has capabilities of both ASA and the firepower. Next is Lena, the underlying ASA-derived process, which is now integrated into FTD, is called Lena. Snort, although very popular, is the IPS engine behind all the inspection. But however, it also does several layer 7 tasks as part of its job. Now moving over to FMC, Secure Firepower Management Center. It's an off-box solution which is used to manage these firewalls. Its primary role is basically to implement configurations, but again, it does provide you reporting as well as eventing and some of those capabilities. FXOS, it's a system that manages the hardware platforms on the Firepower series, like 9K, 4K, 3K, and so on. Data plane is one of the most complex things on this firewall. There are multiple features which combine together to form the data plane. We'll take a look at this using a simple packet flow. The packet arrives on the firewall. It does connection lookup. If it finds an existing connection, then it skips some steps. But if it's the first packet, it goes through the connection table, and before forming a connection, it first does the unnat or the destination NAT, and then looks for a ACL, matching access list. If it finds an access list which is set to permit, it will then hand off the traffic over to Snort, which does several layer 7 tasks, starting from pre-processing, security intelligence, some of the application detection, URL, categorization, network discovery, and eventually it goes down to file and malware policy, and then to Snort. There are multiple points in Snort where a packet could be dropped, but if it eventually gets out of Snort, passing all these checks, it gets handed over back to the Lena, which is all the blue, what you see, and then which is where the flow gets created, and any Lena-related checks happen at that time, and eventually the packet gets routed out of a specific interface. So we'll try to understand the access control rules using a case study, why writing access control rules in a specific way is really important. So imagine there is a Nmap scanner on the outside, and there is an internal web server protected behind a firewall. If you run an Nmap scan targeting that server, if you see there are several ports which are listed as open, all the Nmap scanner does is it sends out SYN packets starting from port 1 all the way till 64535, and all it is looking for is a SYNAC. And if it gets a SYNAC, then it knows that that port is open. Now we'll try to evaluate all the rules which are available on the FTD. By looking at the rules, you would see there's only rule number 2, which is from outside to inside, permitting traffic over to the web server, and the application is HTTP, and it's set to allow. And we don't find any other rules, allowing FTP or SMB or NFS or RDP. You don't have any rules permitting this traffic. So in order to understand why Nmap detected those ports as open, we'll need to understand why or how application identification really works on the firewall. So HTTP, even though traditionally works on port 80, you can customize HTTP to run on port 8081 or any random port. You can configure that, customize it. So as a firewall, before it can really figure out that the port 80 is really HTTP, it needs to send some initial packets. The three-way handshake needs to complete, because in a three-way handshake, there's no payload. So all the information it gets from the three-way handshake is just the destination port, which we already know is port 80 in this case. But apart from that, it needs to wait and do some initial analysis on the application traffic, which starts from packet 4 and above. So it needs to temporarily allow these packets going through the firewall, and once it starts seeing layer 7 application traffic, that is when it knows, okay, is this HTTP? If it is, then it will match the rule. If it is not HTTP, then it will move on to the next rules. In the debugs, let's say we take a communication on port FTP, which runs on port 21. We see that the debugs clearly show the application ID as pending, which means it did not really figure out the application ID yet. And that is the reason why it is temporarily allowing those packets through. So the rule itself is also in the pending status. If we take a look at these rules once again and make some really small changes, take out the application as HTTP and configure your destination port as HTTP now. And let's try to rerun the same scan once again. The earlier scenario where the port 21 packet was temporarily getting allowed, this time the SYN packet is now getting dropped using the default rule. If you look at the scan once again, the scan results shows only the port 80 is open this time. So this is the reason why we need to pay real close attention when we are writing the rules. Similarly, let's take a look at how the rule ordering should look like in a typical scenario, or rather a very simple scenario. If you have geolocation rules set to block, maybe you have some specific countries, you want to block outbound, inbound. So you can configure those kind of rules on the very top, and then you can start placing your layer 3, layer 4 rules, and then eventually place your layer 7 rules, which would be your application ID and your URL. It is suggested that you place these layer 7 rules only for outbound, and if you have any inbound, use the layer 3, layer 4 rules. And then comes your default action. Although this can be a typical scenario, you can always customize this based on your need. There are some guidelines, of course, I would like to highlight. If you have any specific rule, maybe for a specific user, specific IP, those kind of rules should always come on the top. And if you have any layer 7 rules, it is suggested that you avoid as much as possible configuring these layer 7 rules from outbound to inbound, for inbound. If you have any untrust to trust traffic, it is always suggested to subject it under IPS inspection. So we will now talk about security intelligence. In the packet flow, it is in the green. There are a couple of places where security intelligence comes into the picture. By default, any firepower has the security intelligence, which is configured by default, available automatically, does its updates on its own. And Talos maintains this and updates the feeds periodically. It can be a combination of IPs and URLs. So you can configure the access control policy, security intelligence, move all these IPs over to the block list. That way, any client is trying to initiate communication to these bad IP addresses, they get blocked and they are alerted. Within security intelligence, we also have something called DNS policy. The way this works is the firewall will try to interpret by doing a man in the middle for some of the DNS queries. So if you have, let's say, a DNS query from a client trying to resolve a bad FQDN, the firewall will interpret, and if you have configured this to respond with a domain not found, the firewall can respond back to the client. That way, the client cannot even resolve the IP address for this bad server, and the client is now considered safe. This configuration is available from DNS policy. You select all the categories of the Talos feed and move them over to the selected items and select the action as domain not found. Verify that configuration in the DNS policy. The third rule, rule number 1 and 2 are there by default. Rule number 3 is what is created. And then use that under the security intelligence under the DNS tab. Once you have this enabled, the firewall will then start inspecting the DNS queries as well. This is how the security intelligence looks like. in the security intelligence tabs for events, the action is set to block, and you would see the reason why it is blocked, the IP block or the URL block. And then we also can see what category did it match in order to perform this block. And that is listed as a column as well. Now moving on to some layer 7 features. Layer 7 happens in a couple of spots again. So we'll take a look at the first feature, which is TLS server identification. Traditionally, the firewalls depended a lot on the client hello SNI field, which has the URL, or basically the server is trying to contact, and also the server certificate in order to perform rule matching against, let's say, URL or application identification. We, starting from TLS 1.3, this certificate which the server shares is encrypted. So the firewall now lost visibility if you are using TLS 1.3. So in order to solve this problem, Cisco came up with something called TLS server identity. By enabling this feature, the firewall can now gain visibility into this into this communication, even if you are using TLS 1.3. So this configuration can be done using advanced options, and clicking the pencil button there, you can enable it. You'll get an informational message. Once you click on OK, you would be able to save this and deploy. Let's say you configure URL layer 7 URL rules and application identification rules, but you did not enable this feature, you would get a warning. The firewall, the ACP asks you to enable this feature for effective rule matching. Another really, really powerful feature which we recently came out with starting 7.2 is EVE, or Encrypted Visibility Engine. Although these days on a client, there are multiple applications, like your browsers, your custom applications. Every application which are designed or these days are written in TLS. So there may be multiple applications using TLS. So how does the firewall know what application is initiating the traffic? In the past, it was a challenge how the firewall detects the applications, but with EVE and using the EVE library and doing the TLS fingerprinting techniques, the firewall is now able to identify the applications, client OS, and the probability of the traffic being initiated by a malicious application, even without doing a decryption. So this is available only for Snort3, and all you need is a thread license. The configuration is, again, is available in the advanced options, and you just need to move the slider to the right, and you will get an informational message once again. Click on Enable and Deploy. EVE is available for use. Once you enable this, you would probably start noticing the EVE-specific columns in generating information in the connection events. So you would see there are 4 different columns available for EVE. Basically, your visibility process name, associated to the process, and visibility threat confidence, and also threat confidence score. With this information, you would be able to pretty confidently know what application generated that TLS communication, and you can also configure rules based on this information. So if you found out there is a specific application in the events which you believe should not be allowed, you can configure your rules based on that criteria. Now we'll move to network discovery. Although this is not a new feature, but this is available by default. Network discovery is used to build comprehensive map of the whole network. It tries to learn the applications host you have in your network. And this information can eventually be fed to some other features like firepower recommendations in intrusion policy. So the default configuration looks something like this. Only the applications are learned by default, and in the network section, it has IP any as by default in the networks. So it is suggested that you enable both users and hosts, and also remove the any and only use the protected network. This is where all the configuration options are available. So you just delete for the any, and also just check mark the hosts and users. There may be a question on why should we do this, right? I mean, having any includes both your protected network and any network for that matter. The reason for that is we have something called firepower host limit, and this varies on platform to platform. On FMC, on a virtual platform for FMC, this is set to 50,000. So if you start, let's say, learning about all IP addresses the firewall saw in every flow, the source and destination, your clients may be initiating hundreds or thousands of connections over to the internet IPs, right? So the firewall will start learning about all those IP addresses and eventually fills up this count. And by doing so, you are actually not protecting your inside network or your protected network. You're actually building data as if you're protecting the whole internet, which is not good. So that is the reason why you need to use this 50,000 count only to start discovering your inside networks. By default, like I said, the applications, this is how the applications look like in the network discovery data. And now moving over to the SNOT rules. Although we have 4 different predefined SNOT policies available, starting with configuration, connectivity or security, balanced security and connectivity, security or connectivity, and maximum detection. These are in the ascending order, starting from least secure to most secure. Least secure means less SNOT rules enabled. Most secure means more SNOT rules enabled. If you are confused on what SNOT rule, what policy to enable, you probably want to start with balanced security and connectivity as a good starting point and tune from there on. Now, let's take a look at the recommendation rules and configurations. By default, the Cisco recommended rules automatically tune your intrusion policy to enable specific signatures based on the information it learned from applications, servers, the client OS, and stuff like that. In order to really enable this configuration, all you need to do is go to the intrusion policy and fill up this protected networks. Once you put in the protected networks, it will fetch all that data from the network discovery and start generating the rules. Once it generates, you can choose to apply them. Another important piece within the intrusion policy would be the variable sets. The variable sets, although there is one variable set available by default, it contains information about the IP address and ports. This information is used for the firewall intrusion policy to see if an alert needs to really be generated or not. So although most of the variables are available and pretty straightforward, we will be focusing on the external net and home net for the next few minutes. Variables generally provide something called directionality. We'll try to take a look at this using something called the rule itself. This rule has a direction. The TCP, the server port is HTTP ports. The server IP is home net. The client IP and client port are what we saw on the left side. With this direction, if the traffic matches this direction, the content, and also the IP addresses which are listed in the external net and home net, it will generate the alert. There are a couple of recommendations on how you probably can configure your variable set, both external net and home net. The first one is the internal IPS. If you have the firewall deployed as an internal IPS, your team can probably, if they are willing to do something called threat hunting and work on reviewing the alerts and do some fine tuning, You can leave the external net set to any, but decide on how you would like to configure the home net. The second type of deployment method is basically internet edge deployment. If you are looking to configure the firewall as an internet edge firewall and looking only to get minimal alerts, you can configure the firewall external net as anything except the home net, but the home net as the protective subnets. There is another place where the intrusion policy really comes into the picture. In the case study, if you remember, we spoke about how some packets are temporarily allowed through the firewall. Allowing these packets without inspecting would be risky, right? So that is the reason why we have this configuration. You can subject those packets to inspecting while it is doing the rule evaluation. That way, you are not opening up any security vulnerability for allowing the packets temporarily. The next feature, which is another feature which we recently came up with in version 7.2, is the port scan detection and prevention. This needs NOT 3 to be enabled. It can detect port scans and port sweeps. It can be deployed in detection mode or prevention mode. By default, the port scan detection works on all the traffic it did allow, but you can configure it to detect on even the denied traffic. This is how the configuration looks like. In the advanced settings, you can click on the pencil icon. You would see 3 different options. The disable, which is the default setting, the detection, and prevention. There are, of course, configuration parameters on what type of traffic do you want to subject for detection. You can configure specific subnets to monitor. If you have some known scanners and targets which are going to do port scan, you can configure them under ignore scanner and ignore target. While there are some thresholds the firewall provides by default, the low, medium, and high, it can also be customized based on your traffic profile. If your traffic profile is higher enough to meet these thresholds very quickly, you can customize that. If you are trying to enable the prevention mode, the firewall will prompt you, asking you to first enable it in detection mode. That way, you can fine-tune, monitor your alerts, try to configure and get it perfect before you can actually move to the prevention mode. Once the port scan detects there is a host which is scanning, it will block all the traffic coming from that scanner for 1 hour by default. There are some alerts you can monitor just to see if there is any port scan happening in your network. This is under the intrusion events. There's a specific signature which actually flags and generate alert. There are also some troubleshooting commands like show threat detection port scan statistics, which shows on what interface did the scan happen, how many ports did it actually scan, and stuff like that. If it eventually, the firewall decides to block, there are some show commands even to check what IP address are currently in the block state. The show threat detection port scan shun, show shun, and also there is a show ASP counter specifically which monitors the shun number of packets. Another feature is anti-spoof or reverse path check. This is disabled by default. The firewall will try to evaluate if a packet did get received on the right interface based on looking at the routing table, and only if it does, it will continue to process that packet. If it doesn't, it will straight away drop it and flag it. The equivalent command for that would be IP verify reverse path interface, and then the interface name. There are some counters and syslogs which are available in order to verify this. The show ASP drop has RPF violated. As a counter, you can keep an eye on. There's also show IP verify statistics, which lists all the interfaces and the drops which happened on specific interface. There are also some syslogs. If you have syslog server turned on, or you can continue to monitor for these specific syslog. Now moving over to the management and access and control plane. By default, the firewall out of the box allows HTTPS and SSH, but it does allow this from any IP address, which is not really a good practice. You should go to System Configuration Access List and configure only the IP addresses which are listed and from where you would be managing this FMC from, and eventually delete the any which is available by default. And moving to authentication, although there are several authentication methods we support, the first one is internal. Basically, looking at this, it is straightforward. You'll log into the FMC GUI, configure all the user accounts manually. And we also support something called external authentication, where you can integrate LDAP-S, SSO, and Radius. Again, with SSO, you have several vendors which are listed here, which we support natively. No matter what the authentication method is, you can tie the user account over to a specific user role, which is predefined, available on the FMC, or you can create a custom role based on your need. Similarly, for FTD, we also have internal and external. Since there is no GUI option, if it is being managed using FMC, the internal accounts need to be created from the CLI. The external account, the same object which you created for FMC can also be shared for also be shared with the FTD, the LDAP-S and Radius. The only two type of roles which are available on the FTD are basic and config. Basic is very similar to what a read-only user is, and config is similar to like a read-write user. Some of the user configuration options which are disabled by default, but is really encouraged that you review this and enable them. The first option is the password reuse limit. So if you set it to, let's say, 5, you cannot reuse the same passwords what you have used in the last 5 iterations. And the second one is track successful logins. This is basically the number of times you logged in for a specific time period. If you, let's say, set it to 10 days, the firewall will keep tracking the number of times you logged in for the past 10 days. The next option is max number of login failures. If you, let's say, consecutively attempted and failed to log in, let's say after 5 attempts, the firewall will eventually lock out the user. For how much duration does it lock out? This is the setting, set time in minutes to temporarily lock out users. This is the time you can configure to temporarily lock out the user. If a user gets locked out, this is the kind of message they would be getting. In this case, it was locked out for 3 minutes, and that's what it indicates. The administrator can also manually unlock the user if it needs to be. The last setting we are going to look at is the max concurrent session login allowed. So for every user type, here the type indicates read-only user or read-write user, you can configure a specific limit. Let's say a read-only user limit is set to 5. You can have 5 users who can log in simultaneously to the FMC and do their operation. If a 6 read-only user tries to log in, he would not be allowed. Although there are multiple external authentications available on the FMC, which we discussed, you can further harden Radius by making it more secure. You can do this by going to the advanced options and turning on either the SSL and TLS, and then load a certificate. And going to Radius, you can harden this by giving a complex key. That way, it's more secure. The SSO does encrypt all the communication, so it is secure by default. Now moving over to the FTD managed access. Although we looked at FMC, there are very similar parameters available on the FTD CLI as well to harden these internal users. The first one is max fail logins, basically locking out the user after a specific number of times. And next is the password length. This is basically, it just cares about the length. It can be a simple password. The next one is user aging, basically asking the user to change the password after a specific duration. And the last option is enabling strength check. When you enable this, it no longer will accept the simple passwords, and it will prompt the user to only input complex passwords. Similar to FMC, even the FTD CLI has IP any as a management access list, so it does prompt for username password no matter where you're coming from. So it is suggested that you change this. The configuration to change this is configure SSH access list, and it accepts all the CIDR notations. Now looking at some control protocol like NTP, the firepowers depend very heavily on time to do its system operations, like syslog or writing log files, doing some time-based ACL, certificate functions, and so on. So it is recommended that you use a local trusted NTP server if possible for both FMC and FTD. FMC does support authentication. There are 3 types of authentications which are available, like MD5, SHA-1, and AES-128. Now, moving over to VPN, as and when newer and more secure algorithms become available, the older and less secure algorithms gets obsolete. So you will always need to keep updating your IC and IPsec proposals to maintain this security standard. For example, in version 6.7, Cisco decided to either deprecate or remove some of the protocols as they became less secure. For example, Diffie-Hellman Phi is deprecated for IC v1 and removed for IC v2. Diffie-Hellman 2 and 24 has been removed from the support itself. Similarly, encryption algorithms, which are less secure, also has been removed. Moving on to remote access VPN. In the policy settings under SSL, you can actually customize how you want your ciphers and TLS version to look like. If you set the TLS version to, let's say, 1.2, the firewall will only respond to TLS communication, anything above 1.2. You can also set a security level. There are three security levels: low, medium, and high. There's also FIPS for specific type of customers. And there is custom if you would like to customize all the ciphers. So every cipher is categorized into one of these. So if you set it to medium, only medium and higher ciphers get listed in the configuration. So we all know how critical logging and monitoring is. So in order to, let's say, do any threat investigation or connectivity investigation, or looking at any historic logs, you need logging, and also you need monitoring. There are a lot of options available on both FMC and FTD. We'll take a look at that. So although SNMP v1, 2, 3, and all are supported, it is suggested that you use SNMP version v3 just because it is more secure, and version v1 and 2 exchange data in clear text. The configuration looks something like this. You go to System Configuration, SNMP, choose the version 3, and then create a user, configure the authentication parameters and the privacy password, and then eventually configure an access list of the monitoring server from where you're doing the polling. We also support 3 different alerting ways. The first one is email, and second one is SNMP, and the third one is syslog. We all know how good FMC does the job of monitoring its managed devices. So using these alerting methods, it can actually generate logs and send traps over to one of these alert methods. So the first one is syslog. This is how the syslog server can be configured. And the second option is basically the SNMP, again, suggested to configure using version 3. And the third option, basically with email notification. Before you configure the email alert, you need to set up the email notification configuration on the FMC. You can also test it just to make sure it is working, and then use it in the alert configuration. You can set up the from address and to address, and the firewall, as soon as it needs to send an alert, it will using this. We'll take a look at the health alert configuration. All the 3 alerts can be tied to the health alert. In this example, I'm using SNMP and selecting specific modules I'm interested in. And once I configure and the firewall, the FMC detects a health message, in this case, it detected a critical health message for interface status, and it sent out a SNMP trap. The FMC can also send out intrusion alerts based on specific signatures which get fired. So you have this intrusion email. You can select what signatures you want the FMC to send out these email alerts. And once you configure it, the firewall can send out email alerts, and it will send in the form of an attachment. Once you open the attachment, it will list down all the signature firings which happened for those signatures. The same goes on with FTD. The FTD also supports all versions of SNMP. We suggest that you use SNMP v3. There are 3 different types of users: auth, which is basically just authentication; no auth, no authentication, and no privacy; priv, basically authentication and privacy. It is suggested that you use the priv for max security. And this is how the logging looks like. Within logging, we have event data, which consists of both connection events and the system messages. The connection events come from the snort, and the configuration associated to the connection events is found under access control policy under logging section. So these are the 3 different areas. The first option is for connection events. The second option is for IPS events. The third option here is for file and malware events. Once you enable all these events and configure a syslog server, the firewall can send all this event data over to the syslog server. This can be sourced from either the management interface or any of the data interfaces. The FTD syslog ID, it starts with 4300X, 1 being your intrusion, and so on till your file and malware events. These are the same events which are available by default on the FMC as well. You can also enable the Lena side syslogs, which basically contain information about, let's say, HA status or your XLATEs, your anything related to non-data path can be found in Lena, and these can also be exported over to the syslog server. From TAC, it is suggested that you enable this logging at least to informational. That way, if there is any investigation which needed to be done, we have detailed amount of information to parse through. So this is how the configuration looks like. Enable logging, and then you can configure the syslog server set to informational level, and then configure the syslog server itself. By default, it uses UDP on port 5 and 4. You can secure this by enabling this option, enable secure logging. There are a couple of caveats involved with this setting. This is only supported on data interface, and this needs to be TCP. You cannot run UDP with it. There's another powerful feature called NetFlow. With every syslog, flow-related syslog, there is an association with the NSCL ID. So basically, NetFlow does provide a lot of information, very granular information on connection and trends. So if you are using NetFlow, it is suggested that you have this option disabled. You don't want the same information to be sent over both to your NetFlow server and also your syslog server. By disabling this, you're also helping reduce some performance on the firewall. And now moving over to the audit logs, all the activity which is done basically by logging into the FMC, logging out, or making any configuration changes, all of that is logged into the audit logs for audit purposes, of course. There is also compare view available on what changes were exactly done in specific policies in the audit section. You can actually send all these audit logs over to a syslogs if you want. And that configuration is available from system configuration. If you would like to encrypt this configuration using TLS, that configuration is also available. Just by enabling TLS and loading the certificate, you would be able to encrypt it. This is how the audit logs look like by default when you are redirecting to syslog. Although it doesn't have the exact configuration changes, which is a feature on the roadmap right now, but it does include who did the changes and what kind of change was it. So moving on to software updates and content updates, there are several updates like I initially suggested. There are starting from software update onto GeoDB update, VDB update, SRU update, and security intelligence and URLDB. Although all of these can be either manually triggered or they can be scheduled, it is suggested that some of these are scheduled during a maintenance window. So we'll take a look at all of them right now. So the first one is software update. So every organization needs to have a software lifecycle strategy. No matter what your strategy is, you can probably have the upgrade done in a lab device first, or maybe on a least impactful device first. Whatever the strategy is, you need to have one. And the second thing is, always keep an eye on the security advisories, Cisco releases, and also the field notices. Each time when something like this happens, there is a PCERT release which follows. So there needs to be a strategy whenever Cisco releases these kind of PCERT releases. You have a strategy in place in order to perform these upgrades in the short term. There's also Golden Star release. This keeps changing from time to time. The most stable release is tagged as Golden Star. Currently, 7.05 is the current Golden Star release, which may eventually change to a different version. So this Golden Star is given to a release where we know that this is the most stable version available on the Cisco.com website. Most of the time, it is targeted in one of the long-term or extra long-term releases. So this is how the intrusion policy manually can be updated, or it can also be scheduled. Although, like I said, there are some updates which need to be done during maintenance window just because Snort restarts whenever you do that. So one such thing is VDB install and making some configuration changes. You can clearly see there are a lot of red associated to Snort 2, whereas with Snort 3, there's only one. This is another indication why Snort 3 is a lot more better in handling such situations, on top of what we saw earlier, some new cool features which are available with Snort 3. This is with URL filtering. Starting from version 7.3, you have multiple options available on how the firewall does URL filtering. You can choose only the local database. So by default, Talos keeps sending the database, URL database over to the FMC, and then FMC then transfers over to the FTD. It does contain a lot of information about most URLs, but there are only so many URLs it can find in the database. For any other URLs, it needs to do something called URL cloud lookup. So you can customize this option here to include both the database or the URL, or exclusively enable just one. This primarily drives how the firewall uses the uncategorized category in the firewall. There is something called uncategorized category. If the firewall, depending on this configuration, is not able to determine the category, it eventually will start tagging that as uncategorized, and depending on how your configuration is set, it will either allow or deny. There's another parameter called cached URLs expire. So this primarily applies to URL lookups. So let's say there is a unique URL which came to the firewall. The firewall doesn't know anything about it. It will try to do a URL lookup, and the response, whatever it gets, it caches it. And it uses this cache for any subsequent request going to the same URL. This is by default set to never, but again, this category and reputation information is dynamic. So a particular URL today, if it is categorized in one category with certain reputation, tomorrow it may be a different category, or the reputation could change. You don't want to be in a situation where it is doing or using a stale cache. So it is suggested that you change this configuration setting to something like 24 hours or 48 hours. That way you're resetting the cache. The last option, the last topic we have here is the disaster recovery. I would like to emphasize very much on the backup. There have been a lot of scenarios where either we don't have a backup, or we have a backup which cannot be used. So it is always suggested that you use the backup and always store this in a remote storage. That way it is accessible even if there is a hardware failure. Simply by not having a backup, it just leads to a lot of time doing manual restoration and also an extended downtime. So to conclude, we have touched upon multiple features in the product, starting with data plane, started off with a case study on how we should do rule writing and do the ordering, and also explored some layer 7 features, security, intelligence, and so on. And then we moved on to the control plane or management hardening, where we looked at management access list, authentication, user account, and so on. And then logging monitoring. So we looked at all the options available on the FMC firewall. It's a disaster recovery. I would like to call out this note from Art Whitman, which I felt it totally relates to this session. As we have come to realize, the idea that security starts and ends with the purchase of pre-cached firewall is simply misguided. So it is, even though you have firewalls, the configuration decides how secure it is. At this time, I am open to any questions you may have. All right, the question is basically about what's the difference between the different type of intrusion policies, like connectivity or security or connectivity. So all these policies are available by default. The least secure, as the name suggests, the connectivity or security has the least number of signatures. So the CPU resources it needs to process this will be lesser compared to, let's say, a maximum detection, which has the highest number of signatures enabled on it. So I've seen cases where the performance drops, let's say, if it is with connectivity or security, if it is dropping by 10%, this could be like 20, 25%. So it purely depends on the number of signatures which you have enabled on it.
And those signatures are what, sir?
Signatures are the SNOT rules.
Cisco's website, and you can see the models of the different firewalls that you have. But when you look at which one is what, because if you enable security over connectivity, I don't have connectivity out to the internet. That's how bad it is.
Are you really seeing those?
Talking about prepackaged, that's your thing. When you click on your different options in that, you don't know what you're clicking on because it doesn't tell you what signatures.
So, okay, I get your question. So the question again is, you don't know what kind of signatures are enabled in those predefined policies. Okay, I get you. So you can actually create an intrusion policy and use, let's say, the connectivity or security as a base policy.
No, I use connectivity over security.
Okay, you can use that as a base policy, and once you edit it, it will show you how many signatures are actually enabled on it. Like 0?
Yeah. It just passes, pass. It's, yeah, if you really play with it. I have one at home.
Okay, that's the first time I'm hearing the, okay. But yeah, but by default, I've seen a few thousands, and it goes on to like tens of thousands for the maximum detection.
Okay.
I thought I heard it was based on CVSS scores.
Yes.
Basically, connectivity over security is only CVSS 10.
Correct. The lower the level, the lower number of signatures as well. So the performance factor comes into the picture when you keep on going higher.
I mean, I know connectivity, security.
Oh.
That's how bad it is. It blocks everything. But that's okay.
I'm kind of surprised to hear that.
And I just write my own rules.
Oh, you write your own custom rules? Oh, okay, that's good. Hi. Yeah, I'll come over.
Logs, right? The Lena logs, smart logs,
Yes.
regular logs. So if we configure as informational on the syslog side on the ASA or entities, will that show up as these all three logs will be visible, like Lena logs, smart logs,
Yes.
and system logs?
So the question is, if we enable both snort logs as well as Lena logs, will they show up in the syslog server?
If we enable informational.
Yes, informational, yes. So informational, when you enable, it is informational and anything lower. Like let's say if you enable, informational is level 6. It includes level 6, 5, 4, 3, 2, 1, and 0, right? All of them. So they all show up as with the right levels in the syslog server as well. You can filter based on those levels.
And on the ASA, the logs, we cannot watch the previous logs or real-time logs like how we do it on the next generation firewalls and the other vendors, right? Do we?
Are you talking about the buffer logging?
Yeah.
Okay. So the question is about, we don't store a lot of historical data on the firewall itself. Yeah, that's true for the Lena side. So that is the reason why we do store, but the buffer by default is I think 512, and you can extend it to like 32 meg or something, but it's limited. If you turn on, let's say 6 at buffer level, that buffer gets filled up really quickly. So it keeps on rotating that limited buffer, and that could be literally seconds on a busy firewall.
Yeah, I have a second question on that. If you want to troubleshoot VPN,
All right.
it's hard to troubleshoot anything. Like if you want to debug anything, it's hard.
Okay, the question is about if we have to troubleshoot, let's say VPN by turning on debugs, that buffer gets filled.
You cannot see anything.
So, I mean, debugs, if you are redirecting them over to syslog server, you can actually review those in the syslog server.
But debug we cannot, right? Debug is a live debug that runs on the Cisco ASA or
You can actually redirect that information as well.
debug too.
Yeah.
But we don't want debug to happen every time.
Okay.
We want to troubleshoot something, we turn on the debug at that time.
Right.
Usually we send the information along.
Right.
So we cannot, so if you want to troubleshoot something, we cannot go all the time like debug send the syslog server.
And that's not ideal.
Yeah, I mean, you have both options. I'm not saying that that is the only option.
No, for example, if you want to debug SSH, for example, or HTTPS, you run a debug HTTPS, it fills up real quick and you couldn't get down the ASA down as well, right? Depending upon what time you're
It depends. Now, if you are talking about what level of debugs, it depends on, let's say if you have 100 VPNs which are currently down and all of them are flapping or maybe not forming the VPN, it is suggested that you run conditional debug. You pick one peer and apply the condition and then do the debugs. That way your debug information is limited and is focused on one. And if you find one VPN and our...
Log is enabled for the whole FTD group if it's going to syslog server.
I mean, but still one peer. It is, of course, enabled on the FTD, but it is focusing on only one peer, so any message.
You can do that on the GUI.
Yes, not on the GUI. It's only available from the CLI.
But debug, you cannot do peer, can you?
Yeah, you can. Yeah, you can. Yeah. These are called condition debugs. You can enable them. I mean, I think conditional debugs are now available for flows, VPNs, some specific, yeah.
So like today we have informational logs going to syslog server.
Yes.
If I log into the FTD, CLI mode,
Right.
I try to debug. Like if I turn on debug logs, I don't see anything. Because it says it is going to syslog server.
Correct.
You cannot do both. You just do one.
Actually, you can do both.
I tried multiple times, never happened.
So if you have syslog server set up for information logging, and if you turned on debug, it will come live on the screen, but you have the option to redirect. You can do either on the screen or redirect it. You can do only one. So let's say if you are live on the screen and want to debug it, you can actually do that while the syslog is actually doing level 6.
I tried. It's like you have certain options for debug, like to debug.
Oh yeah, I think I probably might know why that is. If you have the FMC configured, set to send the logs over to syslog, it doesn't print on the screen anymore.
Right.
And if you have set that to level 6, it won't even send it to syslog server. So you'll need to uncheck that box.
Okay.
So yeah, you could probably try that.
But with the newer upgrades, like you were saying, like we have to keep top of the upgrades, right?
Right.
The upgrades, the point was, once when we upgraded, the FXOS, the ASA, they're different now. This is getting so much complicated because now if we have ASA running on FTDs, right, which has the ASA image as FXOS,
Yes.
right, and ASA. Now there is anything somewhere malfunction in any of these two, we couldn't realize it. I mean, and then when we downgraded, the path, like, I mean, it's not downgrading because the config is changing.
All right.
Like, you know.
So the question in here is about doing the upgrades along with FXOS and the firewalls. It's kind of complex just because the interoperability and stuff like that. To answer that question, the 9300s and the 4100s is where we have this explicit FXOS and explicit ASA or FTD version. The 2100s and the latest 3100s, they both are bundled. So you don't have to deal with upgrades separately. They both are kind of bundled as part of the same image. So if you're doing FTD upgrade, it in the back end, even without you knowing, it does FXOS upgrade. But when it does, the downtime or the boot up time may be slightly longer, but it actually does very transparent.
Will it change the ciphers as well when it upgrades the OS? Like the SSL ciphers keep changing, right?
Yes, yes.
Duplicate the lower ones and they keep the newer ones.
So it will continue to maintain the configuration.
Yeah.
So manually you will need to review the cipher configuration and modify it, because with upgrade something gets enabled and disabled. You don't want to run into problems.
But
so
if you duplicate it, it won't.
yeah, it won't even allow you to upgrade in those cases.
Oh.
Question on the
Yeah.
IPS. The old ASA IPS had a shun feature.
Yes, it did.
If it fired off, it would block somebody from
Right.
It was predetermined. The FTD doesn't have that.
So the question is about shun feature, which was available on the ASA. Does it operate on FTD? So the answer to that question is, although it is not natively available in the GUI, there are some features like, let's say, thread detection, and the port scan which we talked about, it all uses the thread detection architecture and uses the shun feature.
Right, but if you wanted to do the same feature, did you have that on the roadmap to come back?
So you can still enable shun using the CLI. I'm pretty sure about that. So if you do go to the CLI and do shun and do an IP address,
I wanted to, when it triggers a high alert, like a snort roll fire.
oh, I see, okay.
If it triggers a high alert, just send the guy to
So it's not available as a straightforward feature, yeah. But using correlation and when this alert gets generated, you can actually trigger shun. I've seen that in action in a couple of customers. on the FTD. It's not straightforward. Let me be honest about that. But yeah, there is a way to do that. You will have to create a correlation rule. When a specific IPS alert gets triggered, you can actually let maybe like an ICE system to do a REST API call in order to do the shun. So there is a way to do it. I'll need to figure out how exactly we need to do it. Yeah, exactly. Hi. All right, I think. Thank you everyone for making the time and being available and showing up for the session. I appreciate it.